The last property of water that is due to hydrogen bonding, number 4, temperature moderation. And this is the one that applies to us the most. As biological creatures, we are alive. Most of our body is made of water, and a big reason for that is because all the chemical reactions that occur in our body have to occur in an aqueous environment, aqueous meaning water, dissolved in water. And the biggest advantage that we have of being made mostly of water is that we are able to survive in a wide range of temperatures. So I want you to think about how amazing it is that water freezes at 0 degrees Celsius, but you go all the way to 100 degrees Celsius before, I should probably go all the way to 100 before water actually starts to boil. That is amazing. That is a huge temperature range that water can absorb a lot of heat, a lot of energy without actually changing into a different state, and doesn't go to boil into a gas. Not like carbon dioxide. Think about carbon dioxide. It's a gas at room temperature. So even at 0 degrees, carbon dioxide is still a gas. So you think about water and the fact that it's a liquid over 100 degrees of temperature. That is a whole lot of energy that can be absorbed before water actually changes. Why does that matter to us? Well, it matters because let's say you go to Africa in the summertime and it's 50 degrees outside. You don't boil, like your blood doesn't boil, because at 50 degrees, water is still a liquid. So your blood is still fluid. You can go to the North Pole, you probably need a jacket, but even if it's minus 70 outside, your blood doesn't freeze because you have a jacket on. If you didn't have a jacket on, it would freeze because minus 70, yeah, water freezes at that. But let's say at 0 degrees, right? Or at 1 or 2 degrees, your blood isn't freezing. Because water can like lose and gain lots of energy without changing. It's very, very stable. And one of the really, really important things to stay alive is to have an internal environment which is stable. That, my friends, is called homeostasis. And that's something else that I didn't get to talk about in chapter 2. Very importante, muy importante. So stasis is an internal environment, and homeo is a stable. So again, reading backwards, an internal environment that is stable. Our temperature, our body temperature, I'm sure you are very well aware of what your body temperature is. If you have to go anywhere, you get it taken every time you want to go in somewhere. But it's very stable. You don't have this like between, 25 and 40 degree fluctuation because we would die. So that is 100% due to the fact that we are made mostly of water. So what happens when your body temperature starts to rise a little bit? Another advantage of being made mostly of water is that you start to sweat. So going along with homeostasis, your body's job is to adjust to your outside and inside environment. So if you go outside and it's super hot like it is now, one of the ways that your body adjusts that temperature to bring your temperature down is to sweat. So why do we sweat? Well, sweat is made of 99% water, a little bit of salt, which is why sweat tastes salty. But why do we leak water when we're hot? Well, because when water, a couple things happen. So the first thing that happens, and it's probably more obvious on me because of my pasty ass white skin, is that I become red, right? When like the lighter you are, the more that you recognize that your skin starts to become more red when you're hot. And so why is that? Your blood vessels are going to dilate. That means that they get bigger, they get wider. And why do they do that? Because then you have more blood flow, higher blood flow. And the reason why your skin gets red is because all those blood vessels on the surface of your skin, they dilate, they get bigger, because your skin is the way out, right? That's the last barrier to go out. And then if that doesn't work, because you're trying to bring more blood from inside your body to the surface of your skin to like release that heat, then you'll notice that your skin temperature gets higher as well. So that's the first thing that happens. And if that's not enough to help to bring your body temperature down, then the sweat machine starts. The reason why you sweat is because when that water evaporates, it will take heat with it. So the first thing you do is bring blood to the surface so that that hot blood, you're trying to release the heat just by radiation. And if that doesn't work, then you turn on the sweat machine, you start leaking water, and when that water evaporates, it takes the heat with it. If you don't believe me, I challenge you to get out of the shower, and instead of using a towel to dry yourself off, stand in front of a fan on high. You will see exactly what I'm talking about when I mention how, or like when I talk about why we sweat. Okay, so why does water absorb so much energy without changing? Well, it goes back to this bad boy, hydrogen bonding. So here I've drawn a bunch of water molecules that are attached with hydrogen bonds. And the reason why water absorbs so much energy is because when the water starts to get heated, all of the energy is going to go to first breaking the hydrogen bonds. Okay, so as you add energy, more and more hydrogen bonds are going to break. But guess what? This is still liquid water. Even though the hydrogen bonds are breaking, this is still liquid water. Now there's no more hydrogen bonds. All of that energy is going to go towards the molecules themselves, and it's going to start making them move faster. And as they move faster, they'll gain enough kinetic energy to be able to escape as a gas, and that's at 100 degrees. So that's the reason why water is able to have this wonderful property of temperature moderation, which is what keeps us all alive.